Have you ever had that moment, that really chilling feeling, that sort of ice-cold dread when you realize a file, maybe something really important, is just
Yeah.
gone?
Oh, yeah. It's a horrible feeling.
Maybe it's, years of family photos,
Yeah.
irreplaceable stuff, vanished. Or maybe a work project, dude, like now, and suddenly you can't access it.
In there. Or worse, for a business, seeing an entire database just evaporate.
Exactly. It brings everything to a complete standstill. That awful feeling of being completely helpless.
Hmm.
Well, that's what organizations, big and small, are fighting against all the time.
Mhm.
They're constantly working to protect this huge, growing ocean of critical information.
It's a constant battle.
Welcome to the Deep Dive. This is where we take complex topics, unpack them, and hopefully make them clear, concise, and, well, really compelling. We want to give you insights so you feel genuinely well-informed. Today, we're diving right into something absolutely fundamental, but maybe often overlooked in IT data backup.
Crucial stuff.
Specifically, we're getting into the details of backup topologies. These are basically different ways organizations design their backup systems, the sort of architectural blueprints.
Right.
And then we'll zoom in on the unique challenges and the clever solutions for backup in NAS environments. Network-attached storage.
Yeah. NAS brings its own set of wrinkles.
You could almost think of this as exploring a key part of the backup and archive module, really focusing on that lesson, covering how these data safety nets are actually designed and put into practice.
And our mission today really is to demystify these things. They sound complex, and they can be, but we want to break down the architecture behind reliable data protection.
Okay.
We'll show you how companies make sure their information is safe, how they keep it accessible, and how they can get it back when things go wrong, no matter how big or complicated their setup is.
So by the end, you should have a really solid practical understanding, which is, let's face it, pretty crucial for anyone dealing with information today.
Absolutely. You might even have a few aha moments. It can really shift how you see the data underpinning, well, everything we do on demand these days, and the engineering behind it all.
Okay, let's dive into our first big section then. Understanding backup topologies, building the data safety net. Now, it's easy, I think, for most people to just think of backup as, making a copy.
Right. Drag and drop.
Yeah, drag a folder to an external drive, maybe sync to the cloud. Simple. But in the enterprise world, when you're talking terabytes, metabytes even, of really critical data, it's a much more sophisticated operation.
It absolutely is. Highly planned, strategic.
So why do organizations need these different topologies, these different structures? It seems like a lot of extra complexity just for copying files. What's driving that?
That's a great question, and it really cuts to the core of it. Fundamentally, it's all about finding the right balance. You're balancing efficiency, how fast you can back up, with minimizing the impact on your life systems, your production network.
Right, you don't want backup slowing down the business.
Exactly. And of course, you're trying to optimize costs. Think about it like building roads, like you said earlier. You wouldn't use the same blueprint for a tiny side street as you would for a massive 6-lane highway, right?
No, definitely not.
It's the same idea here. Different amounts of data, different recovery time objectives, your RTO.
At best, you need it back.
Precisely. How much downtime you can tolerate, and different recovery objectives, RPOs.
How much data you can afford to lose, like from the last hour or the last day.
Exactly. All those factors demand different tailored solutions. If your RPO for financial data is, say, 5 minutes, that's a totally different ballgame than archiving old emails where maybe a day is fine.
Okay.
And if your RTO for your website is under 30 minutes, you need a recovery method that's way faster than digging out tapes from storage. Understanding these structures, these topologies, it helps you appreciate the intricate dance of data in a modern setup. It shows you the why behind the what.
And for you listening, this isn't just theoretical IT stuff.
Yeah.
The topology an organization picks, it directly impacts how quickly your data gets backed up, how fast it comes back after a problem, and, maybe surprisingly, how much it costs to keep it safe.
Yeah.
For a business, it really boils down to how quickly they can recover from a glitch, whether that's one corrupt file or a major outage.
It's the difference between a hiccup and a crisis.
Definitely. Okay, so let's break this down, starting with arguably the simplest way, direct attached backup.
Right.
Picture just one server, maybe in a small office. It's got a tape drive plugged right into it, or maybe an external hard drive. That's pretty much it.
That's the essence of it, yeah.
Yeah.
Direct attached. In this setup, The storage node, which is basically the software or the host controlling the backup device,
Oh, okay.
is configured and actually runs right on the backup client. And the backup client is just the server or the machine with the data you want to protect.
Got it.
And the backup device itself, tape drive, tape library, external disk, whatever it is, it's physically connected to that same client, usually SCSI, maybe fiber channel, but a direct link.
So the data doesn't go over the main network,
Well, the bulk data doesn't. The only thing that usually goes over the main LAN, the local area network, to maybe a central backup server is the metadata.
which is like the table of contents, file names, dates, that sort of thing.
Exactly. The what and where, but not the actual stuff. All the heavy data lifting happens locally, right between the client and its attached device.
Okay, so the immediate benefit there seems obvious. It keeps all that heavy backup traffic off the main network, the LAN.
Absolutely. It frees it up completely.
It's like having a private little road just for your backup data, keeping it off the main highway where all the regular business traffic is. For a small setup, that sounds really efficient.
It is. For small, isolated scenarios, maybe one critical server, or a really small business, it's simple and it works well. But its limitations become very obvious very quickly as soon as things start to grow.
How so?
The biggest issue is there's no central management of the backup devices at all.
Ah,
So every client, every server needs its own setup, its own dedicated backup hardware, its own configuration. Imagine trying to manage, tens or hundreds of those individual setups.
yeah, that sounds like a nightmare.
And sharing backup devices,
Yeah.
like a big, expensive tape library. Forget it. You can't do it to save costs or get better utilization. You end up with these little backup silos.
Right, islands of backup.
Exactly. And when you look at the bigger picture, you see why it just doesn't scale for modern data centers. You might have hundreds, thousands of servers. The admin overhead would be insane. The hardware costs would be huge. The risk of errors, it just becomes unmanageable.
Okay, so direct attached is simple, but doesn't scale. So where do organizations go next if they need to centralize things and share resources?
That's where network-based topologies come into play. They offer ways to share devices and manage things more centrally.
Makes sense.
And the first big step up from direct attached is usually LAN-based backup. Sometimes people just call it traditional backup.
Okay, LAN-based. How does that work?
In this model, all the pieces, the clients needing backup, the main backup server coordinating everything, the storage node managing the data flow, and the actual backup device, they're all connected through the regular company LAN.
Okay, so everything's on the network.
Everything. And here's the critical part, the potential challenge. The actual data being backed up travels entirely across the production LAN, from the client, over the network switches and routers, to the backup device.
Ah, and that's where the problems can start, right?
Yeah.
Because that backup data, which could be huge amount,
Terabytes, easily, even petabytes sometimes.
is going over the same network everyone's using for their normal work, their email, their applications, everything.
Exactly. Imagine a busy data center running critical stuff, like a big ERP system or online payments. And at the same time, you're trying to push massive backup jobs across the exact same network infrastructure.
Yeah, I can see how that would cause major slowdowns, like trying to drive a fleet of dump trucks down a busy main street during rush hour.
That's a perfect analogy. The potential for bottlenecks, for crippling performance hits is very, very real.
So how do companies deal with that? They can't just not back up, but they can't grind the business to a halt either.
Right, so they use mitigation strategies. A really common one is setting up separate networks just for backup traffic.
Ah, like a dedicated backup plan.
Exactly. Build a separate highway just for those dump trucks. It keeps the backup traffic isolated so the production network stays clear and performs well.
Okay, that makes sense. But it adds network complexity, I assume.
It does. More switches, more cabling, more configuration. Another strategy, especially for really busy servers, is to install dedicated storage nodes just for them. This takes the load off the main network and the client itself.
Sort of offloading the work.
Pretty much. It's all about finding ways to do the essential backup without disrupting the core business. It's a necessary balancing act, but yeah, it adds layers of complexity and cost.
Okay, now you hear about environments needing really high performance, massive scale. That's where the SAN comes in, right? The storage area network. And that leads to LAN-free backup.
Yes, exactly.
That sounds like a pretty big deal. What makes a SAN different, and why is LAN-free so attractive?
SAN-based backup is often the best fit, the highest performance option when you need to share backup devices efficiently among many, many clients. In a SAN topology, both the backup devices often high-speed disk arrays or specialized backup appliances now.
Not just tape anymore.
Right, increasingly disk and the clients, your servers, are connected directly to the SAN. Now, a SAN isn't like your regular LAN. It's a dedicated high-speed network, usually fiber channel, built specifically for block-level data access. Think raw data blocks, not files.
Okay, so a specialized data network.
Exactly.
Yeah.
And here's the game changer. The actual backup data traffic stays entirely on this high-speed SAN. It completely bypasses the production LAN.
Ah, LAN-free?
LAN-free. The only thing that goes over the regular LAN to the backup server is that tiny bit of metadata, the table of contents again.
So the main business network stays completely clear.
Pristine, untouched by all that heavy backup data. We're talking fiber channel speeds here, 8 gig, 16 gig, 32 gig per second, even faster now. It's a dedicated superhighway just for data blocks.
Wow. The performance difference must be huge.
It's enormous. You're totally unburdening the main network. That means much faster backups, which might let you back up more often. It means dramatically faster restores when you need data back urgently. And overall, much better use of all your IT resources.
And you mentioned disk arrays on the SAN becoming common for backup. That seems like a big shift from tape.
It really has revolutionized things. Disk is relatively cheap now, it's high capacity, and critically, it offers random access.
Right, unlike tape, which is sequential.
Exactly. So for restoring individual files or databases quickly, disk is way faster. It shifts the focus from just disaster recovery to enabling rapid operational recovery, getting things back online fast.
Makes sense.
And connecting this to the bigger picture, that SAN-based disk backup isn't usually the end of the line. It's often your fast recovery tier.
Right.
For long-term storage, for compliance, for disaster recovery, you then often copy or tier that disk backup data off to tape, and those tapes get shipped securely off-site.
Ah, so you get the best of both worlds.
Precisely. You get the speed of disk for quick restores and the low-cost, long-term stability and air-gapped security of off-site tape for major disasters. It's a multi-layered defense. It lets you hit different RTOs and RPOs for different data types, balancing speed, cost, and safety.
So it sounds like it's not always a strict choice between LAN-based or SAN-based then. You mentioned organizations might use a mixed approach.
That's right. Mixed topologies are actually very common, especially in larger, more complex environments.
Why mix them? Why not just pick one?
Well, it often comes down to practicality and strategy. Think about cost optimization. Maybe you use high performance, probably more expensive, SAN-based backup for your absolutely critical databases and applications where downtime costs a fortune.
Right, tier one stuff.
Exactly. But maybe for less critical file shares or development servers where an RTO of a few hours is okay, you use the more cost-effective LAN-based backup. You tailor the solution.
Okay, matching the tech to the need.
And think about different locations. You might have remote offices or cloud servers where putting in a full SAN just isn't practical or affordable. So you use LAN-based there, but SAN-based in your main data center.
Gotcha.
It can also sometimes simplify administration for certain parts of the network. It's really about designing a custom, pragmatic solution for a messy, real-world environment. Getting the right performance and cost balance for different needs. It's like playing chess with your data protection strategy.
Fascinating. Okay, so we've covered the general backup structures. Let's switch gears now to segment 2. The deep dive into backup in NAS environments. Network-attached storage.
Right, NAS, a different beast.
We talked general topologies, but you said NAS has its own unique challenges for backup and recovery. What makes NAS so different that it needs its own special treatment? Why can't you just treat it like another server on the LAN or SAN?
That's a really key point. It comes down to what a NAS fundamentally is. Unlike a SAN, which deals with raw data blocks,
Right, block storage.
a NAS is a purpose-built, dedicated file-sharing system. Its brain, the NAS head, runs a specialized, often proprietary operating system. It's not usually just standard Windows or Linux.
Optimized just for serving files.
Exactly. Highly optimized for file-sharing protocols like CIFS, which Windows uses, or NFS, common in the Linux and Unix world.
Okay.
And because it's proprietary and file-focused, it doesn't act like a regular server where you can just easily install a standard backup agent. Trying to force, say, a block-level backup tool onto a file-centric NAS often just doesn't work well.
Why not? What goes wrong?
Well, you can run into inefficiencies, compatibility problems, even data integrity issues. Imagine a NAS holding billions of tiny files. A normal backup agent trying to scan every single file might be incredibly slow, Or it might struggle to preserve all the specific file permissions and attributes correctly, especially across different client OS types.
Ah, okay. The file-level nature is the key difference.
It is. It means your traditional backup methods might be really inefficient or sometimes just not technically possible without specific workarounds or, ideally, protocols designed for NAS.
So given those challenges, how did people first try to back up NAS devices? What was the early approach?
The early method, before things got more sophisticated, was often what we call the application server-based method.
Application server-based. How did that work?
Okay, so the NAS head, holding the files, would retrieve the data. Then it would send that data over the network to a backup client running on another server, an application server.
So not directly to the backup device.
No, this application server acted as a middleman. Its backup software would get the data from the NAS, process it, and then send it again over the network to a storage node, which would finally write it to the tape or disk.
Wow, that sounds incredibly indirect. Lots of steps, lots of network hops.
It was very convoluted.
I'm guessing that caused problems, all that data bouncing around the network.
Huge problems. You hit it exactly. First, it often overloaded the production network because the backup data traveled twice, once from NAS to the app server,
Right.
and then again from the app server to the storage node. Same data, 2 trips across potentially critical network segments. It could really bog things down.
Okay, double traffic. What else?
It also hammered the application server itself. It used up valuable CPU and memory on that server, resources that were supposed to be running production apps, not relaying backup data.
So it could slow down the actual business applications.
Absolutely, which is exactly what you don't want. It was inefficient, disruptive, and it scaled really poorly as NAS volumes grew. Like your analogy earlier, moving a house by driving it through multiple cities instead of using a highway.
Yeah, definitely not ideal. So clearly there needed to be a better way. Something to get that application server out of the picture and reduce the network traffic. What came next?
You're right. The industry needed something smarter, and that led to serverless backup for NAS.
Serverless. How does that work?
The key change here is that the network file share on the NAS head is mounted directly onto the storage node.
Ah, so the storage node connects straight to the NAS share.
Exactly. So the storage node, which also acts as the backup client in this case, reads the data directly from the NAS head and writes it straight to the backup device attached to it. The application server is completely bypassed.
Okay, now that sounds much better. You're cutting out that middleman.
Precisely.
That must significantly reduce the network load, right? Only one trip for the data now, sort of.
It does reduce the load compared to the previous method, and crucially, it stops draining resources from your application servers for backup tasks.
So fewer network hops, faster backups, less disruption.
Generally, yes. It's a much cleaner, more direct path, big improvement in efficiency, and much less impact on production systems.
But is the data still going over the production LAN in this serverless model?
Good question. Yes, typically it still is.
Yeah.
Because it's usually using standard file sharing protocols like CIFS or NFS to mount that share and pull the data. So while it's more efficient than the application server method, the backup data itself is likely still traveling across your main network.
Okay. Better, but maybe not perfect for really large-scale or sensitive networks.
Exactly, which perfectly sets the stage for the real industry standard for NAS backup.
That would be
NDMP, the Network Data Management Protocol.
NDMP. Okay, I've heard of that. What exactly is it, and why is it considered the standard?
NDMP is an industry standard protocol based on TCP/IP, designed specifically for backing up data in a NAS environment. That's its sole purpose.
Built just for NAS backup.
Built just for NAS backup. It was a game changer because it created a common language. It allows the different parts, the NAS head, the backup devices, the main backup server, to talk directly to each other for data transfer and control in a standardized way.
So it gets around the proprietary nature of different NAS vendors.
Exactly. Before NDMP, everyone had their own way, which made integration a nightmare. NDMP provided an open, vendor-neutral standard.
So what are the big advantages for businesses using NDMP? Why did it take off?
Flexibility is key. Because it's a standard, you can generally back up data from different vendors' NAS devices using the same backup software. That simplifies things a lot.
Okay.
But more importantly, building on that serverless idea, the data typically doesn't go through an application server. NDMP allows for high-speed connections directly between the NAS head and the backup device.
So the data path is even more direct.
Much more direct. The backup data flows straight from the NAS head to the backup device, often completely bypassing the production LAN for the actual data payload.
Wow. So where does the data travel then?
That depends on the NDMP implementation, which we'll get to. But the key is the bulk data stays off the main LAN. Only the metadata, the control information, goes over the LAN to the backup server to keep track of everything.
That sounds like the true LAN-free idea, but specifically for NAS file data.
That's a great way to think about it.
Right.
It's a game changer for backing up large NAS systems efficiently without impacting the main network. Its genius was recognizing that file data needed its own specialized protocol.
Okay, so let's get into those implementations. You mentioned there are different ways NDMP works. What's the first common one? NDMP two-way.
Right, NDMP two-way. In this model, you try to keep the data movement very local. The data flows directly from the NAS head to a backup device that's locally attached to it.
So a tape drive or disk array plugged right into that specific NAS.
Exactly, or attached to a storage node right next to it. The data goes straight there. Only the metadata goes over the regular network to the backup server.
Okay, so it keeps the data traffic very contained for that one NAS.
Yeah.
Sounds efficient.
It is for that individual NAS unit. Very efficient, keeps the data off the main network. Ideal if you just want to isolate the backup for that specific device.
But what's the catch? There's always a catch, right?
Well, the limitation is right there in the description. The backup device is dedicated to that one specific NAS.
So you can't share that backup device with other NAS systems?
Nope. If you have 10 NAS heads, you might need 10 separate backup setups. That means you can't easily centralize your backup hardware management, and you might end up with poor utilization of expensive tape libraries or deduplication appliances.
So it creates those backup silos again just for NAS.
Pretty much. Similar problem to direct attached, just within the NAS world. It can get costly and complex to manage at scale.
Okay, so to solve that sharing problem, there must be another way. That leads us to NDMP three-way.
Exactly. NDMP three-way is designed specifically to allow sharing of backup devices among multiple NAS heads. This is where it gets really flexible and powerful for bigger environments.
How does three-way achieve that sharing? Sounds more complicated.
It involves setting up a separate private backup network. This network, often high-speed Ethernet or maybe even fiber channel, connects all the NAS heads together and, crucially, connects them to the one NAS head that has the backup device attached to it.
A dedicated network just for NAS backup traffic.
Precisely. So when NAS A needs to be backed up to the device attached to NAS B, the data flows from NAS A across this private backup network directly to NAS B, and then NAS B writes it to the shared backup device.
Wow, so the actual backup data never touches the main production LAN?
Correct. It stays entirely on that dedicated backup network. Only the metadata and the NDMP control commands go over the public LAN to the backup server. That traffic is tiny.
So NAS B, in your example, kind of acts as the librarian for the backup device, handling requests from other NAS heads over that private network.
That's a perfect way to describe it. It acts as the data mover proxy for the shared device.
That sounds incredibly valuable for large installations. You can have one big, efficient tape library or dedupe appliance and have all your NAS systems use it without clogging up the main network.
Absolutely. It allows for true centralized management, much better hardware utilization, reduced costs, all while keeping the production network performing optimally. It's really quite an ingenious solution, building that dedicated internal highway just for backup data. Elegant and very scalable.
Okay, fantastic. So we've really covered a lot of ground today on backup architecture. We started with those foundational topologies, direct attached, LAN-based, SAN-based.
Right, the building blocks.
Then we did that deep dive into NAS environments, seeing how things evolved from those clunky application server methods to the better serverless approach, and finally landing on the industry standard NDMP with its two-way and three-way options.
Yeah, it's quite an evolution driven by need.
It really shows how specialized and critical this stuff has become.
And understanding these different ways of doing things, these topologies, it's not just, academic IT trivia.
Yeah, definitely not.
It's absolutely fundamental. It affects data availability, system performance, costs for any organization today in this world where data is the business, pretty much.
Right. Information is currency.
Being able to protect it, get it back quickly, keep things running, that's essential for continuity, even survival. It's not just about having a copy somewhere. It's about having the right copy in the right place, ready when you need it with the least possible disruption. These complex data highways, they're working constantly behind the scenes.
So thinking ahead then, data volumes are just exploding, right? Everywhere. Data centers, cloud, out at the edge.
Yeah.
And it's becoming more critical every day. How do you see backup strategies evolving even further?
That's the million-dollar question, isn't it?
What new topologies might we see to handle things like real-time access demands, always-on expectations? Especially with edge computing, putting data in even more places.
Yeah, the distribution of data is a huge challenge. How do you efficiently back up thousands of edge devices? How do you ensure consistency? Maybe we'll see more sophisticated AI-driven backup orchestration, more peer-to-peer backup mechanisms, tighter integration with cloud platforms.
And how will they keep balancing those needs? Speed, absolute security, and keeping costs manageable. It seems like a constant tension.
It is. It's a non-stop challenge. New technologies bring new risks and new opportunities for protection. It demands continuous innovation, continuous deep dives like this one, frankly. It's going to be fascinating to watch how it all unfolds because it really underpins our entire digital world.